Hi folks, today we're going to talk about symmetry. So symmetry has multiple operations. We're going to talk about rotational symmetry today. Okay, so you can see a few minerals that are sitting here off to the side, and you can see that these minerals have different shapes or morphologies to them. And those shapes are, of course, made up of the different faces. So we can use the arrangement of the faces or the symmetry at which the faces exist to characterize crystal forms and relationships. And of course, this is all part of the characteristic of a mineral having an arrangement of atoms that are very specific to that mineral. Okay, so if we want to look at rotational symmetry, then what we can do is use some models that have nice symmetry, not necessarily the symmetry of something that was grown in nature, but something that represents that. So it's like the perfect version of what would grow in nature. Okay, so if we're going to start with a model, we can start with something relatively simple. And what we want to do when we're looking at rotational symmetry is as we rotate the model or the crystal, we want to know how many times the same pattern appears as that model is rotated 360 degrees. So the pattern that we're looking at here could be this wide rectangle, okay? That pattern has a specific term, and that is called the motif, okay? So we're going to rotate this model and see how many times this wide rectangle appears in 360 degrees rotation. So we know that an axis is a line, and so we're going to imagine that my pencil is a line that goes through the bottom of the model, through the very center point in the middle of the model, and then out the other side, okay? So that's going to be our axis. So it's the axis moves from the top of the model through the center and then out the bottom. So I'm gonna hold my fingers. My fingertips are now the axis, okay? So let's see, here I put a pink square on the top of the model, and we have this wide rectangle. We're going to see how many times we see that wide rectangle, which is our motif, with 360 degrees rotation. So the pink paper just tells me where I started. Okay, so I see that motif one time. I do not see the same motif now. I see a skinny rectangle. There's my starting rectangle motif. So I've seen it now twice, and I continue to rotate. That's not it again. And now I'm back at the beginning. So what I've seen is that this motif appears 2 times. So I can note that as two-fold rotational symmetry. Okay, so two-fold rotation. And really what we have is we're talking about this axis as having two-fold rotation. So what I've found here with my fingertips is an axis of two-fold rotation, and we note that with a capital A for axis and a subscript 2 for two-fold rotation, okay? So we've checked the long direction. Now I would not want to simply let go of the model, flip it around, and count my motifs again, because this is the same axis that I did before. It's just upside down version, right? So we need to look for different axes. Well, we know that there's another axis perpendicular to the first one, and that's shown with my fingertips here. So we can rotate it. We see this motif. Okay, we rotate it. We've seen it one time. Nope. There's the second time we've seen it. Keep rotating it. Nope. And now we're back to the beginning. So again, we've seen the same motif 2 times. So we can note this as another A2, okay? So that's a second one. So we've looked at this axis originally, this axis next. Notice that there's another axis going right through the pink paper, okay? So now we can, I'm just going to rotate my hand, and now we can use this shorter rectangle as our motif. I see it one time. That's a different motif. That's the original motif, so that's second. That's something else. And now I'm back to beginning. So I've seen this same motif again 2 times. So I have another twofold rotational axis. So I can note this as 3A2s, okay? Now that was looking for axes on the faces. And what we want to do is find all the axes of the block. And let me just slide my paper over here. And so we can look at the faces. We could also look at edges, because we can have an axis go from this top edge to this bottom edge through the center of the block, okay? But even though that's an axis, is it a rotational axis? Well, we see this motif of the wide rectangle with the shorter rectangle below it. Let's see if we see that same motif again. We don't see it. We don't see it. Now we see the wide rectangle and the short rectangle, but it's on the top. So that's not an exact rotational axis, okay? That's not the same exact motif. So we get back to the beginning, and we've only seen our original motif one time. So this is one fold rotation, but really anything is one fold rotation, so we don't take note of it, okay? So we've checked this set of edges. We can check other sets of edges, more sets of edges, more sets of edges. So we just want to make sure we do our due diligence and look for all the sets of edges where we could find an axis, okay? And the other place where we can find axes is through the corners. So I'm on the top right corner of my original motif, and I'm on the underside of the block here, where my axis would come out my fingers and go through the center of the block. So again, we're looking for that rotational symmetry. We don't see the exact motif more than once. So this is yet another one-fold rotational axis, which we don't really care about. So we're not even going to report it. Okay, so we can check all these sets of axes and see how many rotational axes that we have, and then we can report that with our notation. Okay, so that's one type of model. Another model would be something like this, okay? So I can show you all around this model, and you'll notice that in this model, I have a motif of a rectangle here with a triangle or pyramid on the top and the bottom. Okay, so that's my motif. And let's start with the sample number so that we know where we started. I'm going to test the corners or the points of this, and I'm looking for that motif, the rectangle with the triangle on the bottom and on the top. I see that motif 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, and here we are back to the beginning. So this would be a 6-fold rotation, and as you probably guessed, the nomenclature would be a capital A with a 6. Okay, so I've tested the point. I can try other corners of the block where my axis would go through the center point of the block. I can try the faces. I can try the pyramid faces. I can also try the rectangle faces, okay? So let's try this one with the 6. Okay, so it's a vertical axis the way I'm holding it now, and I see 2 rectangles and a triangle, or 2 triangles on either side. So as I rotate it, now I'm turning it that way. That is not the same motif, but look, that is, okay? So that's the second time I've seen it. That is not a repeat, and this is back at the beginning. So I've also found an A2, okay? So now I need to test all of the faces. So I'm going to test this set, the axis that goes through that set of faces. I'm going to test the axis that goes through this set of faces with the opposite there. And I'm also going to test this set of faces. Okay, and what I'm going to find is that there are multiple axes of rotation here. So that's the faces that I've tested and the corners that I've tested. I also want to test the edges. So the edge is the intersection of two faces. So I have a face here and an axis goes down through the direct center of the block by tapping on or putting the end of the axis at the bottom opposite edge of the top one. Okay, so now I have one rectangle with my two right and left facing triangles. Okay, I rotate it. No. There's the same motif. Okay, I rotate it again. There I am back at the beginning. So I've found another A2 on this block. Okay, so I need to go through all the faces. In fact, let's write that down. All the faces, all the edges, and all the corners or points to look for these axes. And I keep a running tally of all of them. Now I haven't finished this block because we haven't tested all the edges and all the corners and all the faces, but at least you get the idea. Okay, so we can have in nature, minerals exist with twofold rotational axes. And we saw that with the original model, and that is A2. We can have threefold rotational axes, and that would be something like this, where we have an axis going straight up and down, straight up and down the way I'm holding it. And so we can rotate it. So my fingers are now the axis, and I see a rectangle, and I see it 1 time, 2 times, 3 times, and now I'm back at the beginning. So that would be threefold rotation, which is an A3. We can have fourfold rotational axes. So in this example, my fingertips are the axes. This is the starting point. I see a square, and I see it 1 time, 2, 3, 4, and we're back at the beginning. So that is a fourfold rotational axis, and that is an A4. And then remember, this model is the one that had the sixfold rotation, and that is the A6. So those are the ones that occur in nature for minerals, okay? So if you find something else, if you find an A8, then you've gone a little bit off. So make sure that all of your rotational axes are truly one of these options. Okay, so that is rotational symmetry in a nutshell. So I want to introduce myself. I am Rachel Teasdale. I teach mineralogy and lithology at California State University, Chico, here in Northern California. And while I'm not a mineralogist, I am a geologist, in fact, a volcanologist. I study lava flows, and I use minerals in my research by melting pieces of lava in a furnace, and then I cool the molten material at controlled rates to try to better understand how crystallization occurs in a lava flow. So while I'm not a mineralogist, there are lots of people who use minerals in lots of different ways. So I hope you enjoy your mineralogy course.